We have customers who have started with us with maybe 5 servers, and then they went to maybe 10. And suddenly, a year later, they are in hundreds of servers, and we have customers who have thousands of servers. So offering agility to all of them through that life cycle is really a challenge. And we're not claiming that we're there. In fact, we ourselves are experiencing the pains of growing up. And as we live in agility, that means that we try to provide the functionality as soon as it's available. That doesn't mean that it is the final solution for every scaling. I'm going to show you some of the work that we've been doing in the product to really go to the next level. Once you have a big deployment and you have hundreds of servers, what are the tools that we're going to provide you so that you can maintain agility in managing your servers? We introduced monitoring in 2008. At that time, we gave you the ability to go server by server and look at a specific metric. And then we introduced deployments, and then there you can go and select a server from a deployment and a metric and construct maybe a page of 20 graphs that were important to you. Now, once you go to tens of servers, suddenly that becomes difficult to use. It's difficult to go and scroll the pages. So at the beginning of this year, we introduced a new concept that is cluster monitoring. And the idea there is that if you have servers of a specific class, they may be databases or maybe front ends, you would like to see all of their graphs together so that you can compare the performance. And that's the idea behind cluster monitoring. And for those of you who haven't used it, let me take you through the paces. If you go to the dashboard, to any deployment that has servers running, and then you go to the monitoring tab, then previously we give you the ability to select one server to focus on. Now what you have is a link that says, well, you can create a cluster monitoring for your deployment. And then what you do there is that, let me see if I can point here, it's difficult. You have to basically specify which of the maybe hundreds of servers that you have in your deployment you want to select. And in order to do that, you can select them by the server template they use. You can put the regular expression that basically matches to the name. Or you can select them based on the name, if you have the discipline of naming your servers in the correct way. Or you can use tags, and tags most probably is the more forward-looking kind of way of doing things in RightScale. And you can tag your servers so you can select them by a tag. Once you have selected the servers, then you have to basically pick up the metric that you want to focus on. And you can see that that's the second arrow that I'm showing here. And in this particular case, I think we're focusing on the overall CPU. And what happens is that if you have 200 servers and maybe 20 front ends, if you put the right pattern, you're going to select the 20 front ends, and then for all of them, the same metric is going to show as little graphs. And you can see it here in this example that 8 app servers are being displayed, and basically the status of all of them. The nice thing is that you can basically manage this graph with a single line of control. And here in this particular case, you see that you can choose between a tiny graph, a small graph, or a large graph, and you can also change the scale as you are familiar with that. And the nice thing is that you click the button, and in a couple of seconds, all the graphs basically are updated. So it's very nice. It gives you a way of looking either very small graph, you can have maybe 20, 30, and it's very convenient. The problem with this is that once you go into the hundreds of servers, suddenly having these little tiny graphs, maybe 2 pages, it's not really that very useful. So we experienced that ourselves, so we want to go to the next level, and we've been working in producing 2 different kinds of graphs that I think are very cool and you're going to like. Coming soon is the first one is what we call stack graphs. What we do in stack graphs is that we put all these graphs together into a single graph, maintaining the horizontal and vertical dimensions, but we use different colors and we aggregate the contribution of each of the different servers. And this is very convenient because as you add servers, you see that their individual contributions change, but you are more interested in seeing the aggregate contribution. Okay? And this particular case is taken from some of our servers. You can see that as in the previous situation, you have 6 servers that are very computing and producing work. One of them has been idle for some time, basically for a long time, and another one has been launched. Well, here we basically capture that. You mostly see that the 6 servers that are working, this is the contribution that they have. So this is a very nice thing. You can stack up to 100 graphs, 100 different servers if you basically select the correct pattern, and they will be shown here. The idea of heat maps is that we change the dimensions. We continue to use as the horizontal dimension time, but on the vertical dimension, we basically assigned a little road to each of the servers, and the metric itself, we use colors to basically give you the magnitude. So as you can see here, let me go through the specifics. Here is the CPU, the load. You can see here that you have all the servers basically being assigned a road. Then the scale, the lowest value is going to assign maybe a cool color. And as the magnitude increases, we're going to basically give you something that reflects heat. So then these are very convenient because it highlights what you can see here, that is the valleys and troughs of the daily usage patterns. During the day, users basically are actively on the site, and during the night, the activity goes down. So you can see that clearly in the reds that happen every day. And it's easy to see patterns as before. The server that was idle is shown here, and the server that is being launched is in this road. Currently, you can stack up to 100 graphs, and you can 100 servers. If you select a pattern that is going to satisfy more than 100 servers, we use basically heuristics that tries to take some fraction of the oldest servers that you have launched, some fraction of the newest servers, some fraction if there are different server templates, but they share the similar names. We also try to do some balance there. And finally, we use some randomized graphs so that you have basically a snapshot or a sampling of all your servers. Now, let me show you how we're using these because, well, at RightScale, we use RightScale to manage our site. So we are the first ones who are basically asking to have these features. This is a specific example of that happened in real life, in which we have basically our monitoring servers. We have a lot of them, and here we're focusing on 100 and trying to detect things that are maybe wrong with the system. And this is a specific case that happened a couple of weeks ago, that suddenly, at some point during the day, we start receiving alerts that some of the servers were overloaded. And you can see that those servers are the ones that basically are here in the red, that for the metric of the wait percentage of time doing disk I/O, basically was higher than what we expected. And it was clear to see these here. Either using a stack graphs or using the conventional cluster monitoring would have been impossible, has been very difficult. So right now we can focus very fast. We're showing here up to 60,000 points. Basically, there are 100 servers times the number 600 points per graph. So it's a lot of information that is very conveniently displayed for you. We believe that both stack graphs and heat maps are going to be very, very useful for you. So if you are being using RightScale and you have hundreds of servers, I think you're going to be very happy to start using this. Now, what is the status of cluster monitoring? Now, these are just different pieces in your toolbox. I'm going to continue increasing that toolbox. So cluster monitoring are individual graphs. They are good for dozens of servers and displays a standard graph and allows you to manipulate it in a very easy way. However, they have limitations. Stack graphs, what happens is that it allows you to see the contribution of many servers in a single small graph. It's good for aggregating performance. However, it's difficult to look the individual servers, and for that reason, the heat maps is another dimension in seeing the information in a proper way. Now, heat maps display a bar for each particular server. It's great to see uneven distributions, and also it's very good to quickly spot any anomalies or any patterns. The status of these is that they are on beta. They're coming very soon. And in the next release, some of you, if you want to start using them, you can basically contact us and we can make available to you. Now, if you have your servers here represented here, and they have been configured to send monitoring data to our servers, that continues to be the same way. They are basically collected here. The information is kept in memory, and they're basically pushed into disk at a certain interval so that any queries coming from the dashboard, we can satisfy very quickly. Now, the cluster monitoring is just another layer that we're putting on front of these monitoring servers in which they use as backends the original monitoring servers. They pull the information, combine it based on the type of graph, how many of the servers you're putting on a stack graph, on a heat map, and once they produce the graphs, they send it back to the dashboard. So in a way, it's just another layer that allows you to add complexity without having to change anything on the back end. The current status is that individual graphs are available today, and stack graphs are in a private beta, and initially going to be available for the US East, Rackspace, and private clouds only. Let me move to once you have spot certain problems in your servers and you want to do changes on them, how can you do that efficiently? And here the challenge is that on a dashboard, we use pagination to show you only a slice of things. And right now it's like 20. Well, we have some customers that have, for example, 30,000 snapshots. Imagine trying to manage 30,000 objects in a convenient way through a dashboard interface. So we have put a lot of thought about how to do it, and here's it's a trade-off on trying to operate in a lot of servers, only looking a very limited view. Now, the way it works is that we have some functionality, for example, the filtering. We basically offer some filtering that allows you using, again, the server template or the name or maybe the AWS IDs to identify patterns so that you can only see some group of maybe servers or maybe images or maybe volumes. In addition, now we have extended that so that at the bottom, we allow you to basically select with checks either all of the resources that you're seeing on a page or all of the resources that are in all the pages, including the ones that you're not seeing. And once you have selected all of them, you can apply an operation on all of these resources. Now, you have to be very careful because if that operation, like in this case, is to delete, well, you are basically operating on as many resources as you have selected. Now, in some cases, that presents some difficulties for us because the operation that you may want to apply not necessarily is possible on the objects that you have selected. For example, you may want to delete a volume, but the volume is attached to a server. Well, we're not going to let you that. So we make a best effort in which maybe the number of objects that you're going to operate on is going to be less than the number you selected. And we give some information about that. Secondly, we don't want to do this operation synchronously because, again, if you want to delete 10,000 snapshots, it's going to take a long time, and you're going to tie a lot of resources and going to prevent you from continuing doing work. So the way we do it right now is that we take a small group of maybe 20 of these objects, and we operate synchronously on that, and then we basically create work units so that the other resources, their action happens basically on the background, and we give you some information in the notification of events when that basically is how that is making progress. Let me change to the API. I think once you are doing serious work on RightScale and you have hundreds of servers, most probably you don't want to use the dashboard, but you want to explore the API as much as possible. We introduced the API 2 years ago. We have been very conservative in basically extending it, and the reason is because at the time we believed that things were going to change a lot in cloud computing. It was only Amazon, the only cloud that we were supporting, and we then wanted to put in the API some things that it was going to be difficult to change later on. So we have been conservative in that respect, and we are the first one to admit that there are some limitations in our API, so we're basically doing a lot of effort in producing the next generation of our API. There are some goals that we want to achieve there, and the goal is that we want a single API to manage basically resources on multiple clouds. So I think we're a multi-cloud company, we believe in that, and therefore our API should basically reflect that. The second one is that we want to allow our users and customers to be able to write scripts and to automate the processes by talking directly to us without having to pass to the dashboard. You can see that even the use of RightScale is very different whether it happens through the API or it happens to the dashboard. And I think this is reflected in these two graphs. Here, for example, is the activity that we see on our API servers. And as you can see, the activity is constant all the time. And the reason is because we have customers that maybe every half an hour or every 10 minutes are basically querying the status of the resources, and they're taking that information, massaging it, and presenting it in some way on their own systems. How we're going to basically move from API 1.0 to 1.5 and 2.0. And the idea is that we're going to use the API 1.5 as an intermediate step. The goals there, the goals are to support Rackspace and Cloud.com or Eucalyptus, and basically offer this API only for that. We're not going to offer the API for EC2, and the reason we're going to basically continue using the API 1.0, we want to improve the design. We want to also, we're adding nice things. For example, with the API, you're going to be able to self-discover resources. You're also going to be able to identify the operations that can be applied to a resource. I think that's something that we find very useful, and that once you start using it, are very powerful in order for you to automate basically the processing of handling a lot of resources. We're going to wait, and once we release the API as a 2.0, then it's going to be for basically all the clouds that we manage in RightScale. And we expect that the structure is going to be the same. So once you get comfortable with 1.5, I think it's going to be very easy for you to migrate to 2.0. So I think the final thing I want to talk about is something completely different. It has to do with a little bit of how to display information in a convenient way. We basically try to do a lot of effort in providing the right information in the right way, but it's impossible to satisfy the different needs that our users. Either we have companies that are very small shops, or we have companies that basically are just exploding the number of things that are doing in the cloud. And we have financial services companies, we have Web 2.0, we have gaming companies. And the kind of things that they would like to see RightScale basically providing in terms of views is very different. So in that respect, what we want is to open our dashboard and allow you to build your own dashboard. And in that case, this is the notion of widgets, in which you can create your own views. And the way to use it is that the first page is where we normally show an overview or your deployments, or basically the monitoring graphs and the alerts. We're going to add another tab that is called what we call widgets. And then you can put any widgets that you want. And here we're just giving you 4 examples. In the first one, on the upper left-hand side, someone may want to, for example, use bar graph to display the number of servers and the state. How many servers are stopped, how many servers are running, and how many servers may be stranded. So I think that's the first graph. And you may do that on a specific deployment, and that's what we're showing there. You may want to show your information as a pie chart. And in this particular case, what we're showing is, well, what is the distribution of servers across the different availability zones in Amazon? So this is very important, especially if you are buying reserved instances. It's always tricky to play this game of saying, well, I have these resources, but I have to make sure that they go to the same availability zones. Otherwise, basically, I'm not reaping the benefits of the savings. Now, sometimes you may need to launch 20 servers, and somehow at that particular time, Amazon doesn't have the resources, so you may have to use other availability zones. So knowing exactly what is the distribution is very valuable. At the bottom, we show you a different kind of information, and that one, what's interesting is that it's exploiting information that we already provide in our dashboard. But you may want to make use of these attributes and objects that we're basically exposing to you so that you can massage them and present it in a different way. If you are familiar with our site, you have seen these green lights that basically are indicating that the servers are in good shape. You can use the links. So you can put the links that may, once you click, may take you to a page, to the show page of that particular resource, and you can go deeper. And you can also use some coloring, maybe to flash some information if you like that kind of things. And you can do it either for individual servers or for deployments. It's up to you. Here also, we're using the lights that we normally show to tell you how many servers you have in that deployments and the particular state of each server. We're using some open source libraries, and in particular Liquid, and Liquid is becoming very popular because it's a secure way of allowing customers and users to basically write code that can be executed on your servers in a secure way. Some of our friends, New Relic, uses it in the dashboard, and some other big web companies are offering that. Now, the idea is that the data is drawn from predefined data collections and definitions that we're going to continue expanding and providing to you, so that you basically are doing all the hard lifting so that you can just combine it in a very easy way. As an example, here is one of the views that I showed before, how easy it is to, in less than 20 lines, using some simple tags and some basically collection of objects in which you iterate and get some properties from them, you can basically build something that is very, very nice to see and operate. And you just basically have to put some information about the name of the widget, the timing about how you want to do the refreshing, and then select the data source, and then how to filter them. Finally, a little bit about what's ahead on the roadmap. We're basically going to focus on providing more tools to manage collection of servers and other resources. And I think it's something that we're basically putting a team of people who are dedicated in working on that. We want also to increase the sysadmin efficiency, because RightScale basically is a management platform that is mainly used by system administrators. So we want to really leverage that and provide the most value for them.